Here we have limit x tends to 0, greatest integer function of 100x by sin x plus again greatest integer function 99 sin x by x. Okay, we know our when x tends to 0, sin x by x or sin theta by theta, this graph will look something like this. Okay, so sin theta is always lesser than theta, but when theta becomes very small, then sin theta will become very close to theta, and that's why this fraction will tend to approach 1. We already discussed this. For example, why does this happen? For example, if you take a circle, okay, circle of unit radius, that means OP is 1, OA is 1, and let's say this angle is theta. Theta is in radians, right? Then let's draw this right angle triangle. Let's take a random point P and I draw a right angle triangle with OP as hypotenuse. Naturally, what is sin theta? That is opposite side by hypotenuse. Obviously, hypotenuse, the value of hypotenuse is 1, so opposite side be equal to sin theta, right? So basically, PQ is equal to sin theta, right? Now at the same time, this theta is in radians. We know r theta is the length of this arc AP, this arc, right? This arc is r theta, right? We know this formula, right? For example, if this entire circle, if it is the entire circle, then entire angle will be 2 pi and 2 pi into r, which is the total circumference of the circle. Now it is just theta, so that's why it is r theta, because r is anyway 1, right? R theta. Now we can clearly see from this figure that in this triangle PQA, PQ is always lesser than PA, because PQ is a leg and PA is a hypotenuse. This is also a right angle triangle, right? And PA is always lesser than RPA. Why? Because PA, this line, it's a line joining these 2 points, whereas it's a curve joining these 2 points. So obviously PA is always lesser than RPA. Now what is our PQ? PQ is sin theta, and what is our arc? Arc is theta. So sin theta is always lesser than theta. Naturally, right? If the P moves here, then the difference increases, right? PA is a straight line and this is a curve. When P comes to this side, closer and closer here, that means when theta becomes smaller and smaller, then it is a comparison between a line and a small curve like this, right? That's why then sin theta will come closer to theta, but is always lesser than theta. So when theta is very small, the sin theta by theta will tend to approach 1. That is what we have drawn in this graph also, right? Naturally, sin theta by theta, sin x by x will tend to approach 1, but is always lesser than 1. So here what we are saying, this is 99 sin x by x is something like 99 into some 0.99999 something. So it is lesser than 99, right? 99 into 0.99 something is something like 98 point something, 98.99, whatever. Similarly, sin x by x is always lesser than 1. X by x is less than 1. That means x by sin x is always greater than 1, right? It is just the inverse, right? So that means 100x by sin x is this x by sin x is always greater than 1. That means slightly above 1, right? Slightly above 1. This will be 100 point something. Okay, basically we have what? We have greatest integer function of 100 point something and plus greatest integer function of 98 point something. Right. So what is this? The greatest integer less than 100 point something is 100 and this is 98. So total is 98. Right, guys? When x tends to 0, it doesn't matter whether x is approaching from the left side or right side. Okay, whether it is approaching from the left side or the right side, sin theta is always lesser than theta and it will try to approach 1. So obviously if you take the inverse of this x by sin x, it will look something like this. It is always x by sin x is always greater than 1, but as x approaches 0, that will be whole here also, x approaches 0, then this will get closer to 1. So 100x by sin x is slightly above 100, 99 sin x by x is slightly below 99. So greatest integer function together of these two is 100 plus 98. Right, guys? Thank you.